Alright, so we're going to talk about 30, 60, 90 special right triangles and kind of go over that a little bit today. Your learning target is I can justify and apply the properties of 30, 60, 90 triangles. Alright, so first let's go over what is a 30, 60, 90 special right triangle. And what that is in a 30, 60, 90 triangle, the length of the hypotenuse is 2 times the length of the, gotta write this down, it says shorter leg. Okay, the hypotenuse is 2 times the length of the shorter leg. So in that blank you want to put shorter. Now the next part of this is it says the length of the longer leg is the shorter leg times the square root of 3. Okay, so the longer leg is the shorter leg times the square root of 3. Let's draw this real quickly. Alright, so we've got you should have drawn something like this. If you need to pause the video, go ahead and pause the video. Where we have a 90-degree angle, a 60-degree angle, and a 30-degree angle. Okay. Now it says that the hypotenuse is 2 times the length of the shorter leg. Your shorter leg is always going to be the angle across from 30 degrees. Okay, that is always going to be the shorter leg. So we're going to call this part right here, we're going to call that S. Okay. Now the hypotenuse we said is 2 times the shorter leg. So that's going to be 2S. And the length of the longer leg is the shorter leg times the square root of 3. S times the square root of 3. So that little diagram, that's going to really help you understand how all of these things are connected. Okay, your key concept here is to solve problems involving the special right triangle, the 30, 60, 90, we first need to identify all the sides. Identify the shorter leg, identify the longer leg, and identify the hypotenuse. Okay, the second step is to substitute those values in for the following formulas based on what is being looked for. Okay, so the first formula here is we have the hypotenuse, and that is going to equal 2 times the shorter leg. Okay, this is just like what we put in our little diagram above, but we're just going to write it into what our formulas could be. Okay, the second one would be that the longer leg is equal to the shorter leg times the square root of 3. Okay, and we can use those two formulas to solve depending on which side we're trying to find the length of. Okay, and then obviously the last step would be to go and solve. Alright, example 1 says to find the missing side lengths, and we need to leave our answers as radicals in simplest form. So here's the information we know. We know that the hypotenuse, remember the first step is to identify all sides. The hypotenuse is the length across from the right angle, so 4 times the square root of 6. This would be our hypotenuse. Okay. M is going to be our longer side, and the reason why we know that is because this degree is 30 degrees, this is 60 degrees, and remember the 60-degree angle is going to be our longer leg. The 30-degree angle is going to be our shorter side. Okay, so we're just abbreviating those. We're identifying which ones are which. And now we need to use our formulas. Okay, now we know the hypotenuse is equal to 2 times the shorter side. So our hypotenuse is 4 times the square root of 6. That equals 2 times the shorter side, which is n. Okay, now we've built an algebraic equation, and we can solve this algebraic equation for our variable n, and we will know how big or how long the short side is. So we divide by 2 on both sides. We see here that the 2 will cancel out with the 4, because 2 goes into itself once, 2 goes into 4 twice. And we're left with, the 2's cancel here too, 2 times the square root of 6 is equal to n. So the n is equal to, the shorter side is equal to 2 times the square root of 6. Now for the longer side, the longer leg, that formula was the longer leg is equal to the shorter side times the square root of 3. Okay, so our longer leg, which was m, is equal to our shorter side, which we just found to be 2 times the square root of 6, times the square root of 3. Okay, now we can simplify this a little bit. Remember, we can combine what's inside of these radicals here because of the product rule of radicals, and where that is going to equal 2 times the square root of 18. And now we know we can simplify this radical. Okay, it's not in simplest form. There's some free perfect numbers that we can take out of here, and so we know that 18 has 9 and 2 that go into it, 9 being our perfect number. M equals 2 times the square root of 9 times the square root of 2, which means we're left with m equals 2 times the square root of 9 is 3 times the square root of 2, and finally that leaves us with 6 times the square root of 2 for our longer side. Alright, so example 2, we're doing the same type of thing, but what we'll notice here is that if we try to use the first equation, that the hypotenuse is equal to 2 times the shortest side, we're using two things that we don't know yet. So let's go and skip the first equation. Let's use the second equation, which remember is that the longer leg, which is 5 times the square root of 6, and we know that because it's opposite the 60-degree angle. 5 times the square root of 6 is going to be equal to the shorter side, which is y, times the square root of 3. Okay, now we can solve for y just like we normally do, right? This is just algebra. We're going to divide by the square root of 3 on both sides. We end up getting 5 times the square root of 6 divided by the square root of 3 is equal to y. These cancel out. Okay? Now we know that when we have a radical in simplest form, there is not a radical in the denominator. So we need to get rid of that radical in the denominator by multiplying it by a square root of 3 over the square root of 3. Because when we multiply those two fractions, we end up seeing that 5 times the square root of 6 times 3 is 18. So we'll have 5 times the square root of 18 divided by the square root of 3 times the square root of 3 is just 3, is equal to our y. Alright, we're still not done yet because there's a perfect number we can take out of 18, and that perfect number is 9. And so let's rewrite this now as 5 times the square root of 9 times the square root of 2 divided by 3 is equal to our y. Man, there's a lot to do on this one. The square root of 9 is 3, so we have 5 times 3 times the square root of 2 divided by 3 is equal to y. And we see those 3's are going to cancel out. Okay? They cancel each other out. And so what we're left with then is 5 times the square root of 2 is equal to y. Okay? That is the length of our shorter side. Now we need to go and find what the length of our hypotenuse is. And the hypotenuse, remember, x, I'm going to write it up, x is equal to 2 times the shorter side, which is 5, sorry, messed that up, square root of 2, I'm writing this backwards now, times 5. And now we can just combine those like terms, right? The 2 and the 5, we can multiply those together. X equals 10 times the square root of 2. And that's what we're